When we normally talk about fundamental numbers in math, we kind of bring this built-in expectation of absolute static rigidity.
Right. Yeah, like it's a fixed thing.
Exactly. I always think about, a child's wooden building block. You hold a single block in your hand and it's just one block. It
Right.
doesn't change. It doesn't like fluctuate or buzz. It just sits there being exactly one.
Yeah, it's the ultimate binary state, really. And
Yeah.
you either possess one discrete block or you possess 0 blocks. There's no in between. And for, well, the vast majority of human history, that integer, the number 1, has been the unquestioned bedrock of how we quantify our reality.
It is. It's the most basic concept we absorb. We learn it as toddlers, right? Counting our fingers. One is one.
It's clean.
It's clean, it's comforting. We deeply want our foundational measurements to be solid like that. But then you step into the world of theoretical physics.
Oh, yeah, where nothing is clean.
Right. Specifically, when you look at the deep architecture of the quantum vacuum, suddenly that solid wooden block isn't solid at all. We are looking at a mathematical landscape where the number 1 is, well, it's vibrating.
Which requires a massive, and I mean massive, paradigm shift for anyone trying to visualize the universe.
Mm.
We are forced to completely abandon the idea of a static, silent baseline for reality. And instead, we have to embrace a baseline that is perpetually humming.
And that hum is the central mystery we are unpacking today. Welcome to this deep dive. We are taking a journey to the absolute edge of theoretical physics today.
Deep in the weeds on this one.
Oh, very deep. We've got a huge stack of research in front of us centered around a dense but honestly potentially revolutionary framework.
Right.
It's titled the EGM derivation process.
EGM standing for electrogravimagnetics.
Exactly. And our goal today, our mission for this deep dive, is to map out this radical new perspective because it attempts to do what physics has basically struggled to do for a century, which is bridge the microscopic quantum world with the massive cosmological universe. And remarkably, it tries to do this without breaking the established rules of the game.
Which, if you know the history of physics, is the holy grail. I mean, for nearly 100 years, modern physics has operated like a completely divided house.
Yeah, two different worlds.
Exactly. On one side, we have general relativity. That's Albert Einstein's masterpiece. And that handles all the massive stuff. Black holes, planets, the curvature of space and time.
The big stuff.
The big stuff. And then on the other side, we have quantum mechanics, which governs the tiny stuff. Quarks, electrons, the fundamental forces.
And they don't play nice together.
No, not at all. I mean, both theories are incredibly accurate in their own domains, but mathematically, they refuse to speak the same language. If you try to mash Einstein's equations together with quantum equations, the math usually just breaks down. It explodes into impossible infinities.
Right.
But the source material we're looking at today presents a mathematical unification that is deeply elegant because it attacks that division at the very root.
And the hook for this entire conversation, like the mind-bending premise that sets all of this into motion, revolves around what we just touched on, the number 1.
Yeah.
And I really want to emphasize this for you listening. If there's one thing you keep in the back of your mind today, it is this specific formula. The core focus of this EGM framework is that by mathematically redefining the number 1 and combining it with the principle of mass-energy equilibrium,
Which is crucial.
super crucial, combining those two things generates something called the quantum vacuum spectral limit, or the QVSL. And it's this QVSL that miraculously results in scale unification.
Scale unification, yeah. That is the ultimate payoff here.
Let me just repeat that formula so it sinks in. The number 1 plus mass energy equilibrium generates the QVSL, which results in scale unification.
And scale unification means that the exact same underlying geometry, the very same set of mathematical rules, can seamlessly explain the microscopic radius of a single proton
Wow.
and the macroscopic expansion rate of the entire observable universe.
The exact same math for a subatomic particle in a literal galaxy. I mean, I know that dropping terms like quantum vacuum spectral limit right out of the gate might sound like we're gearing up to read a dense university textbook.
It sounds intimidating for sure.
It does. But stick with us. We are going to translate this. We really want to understand the how and the why of reality's architecture.
Yeah, the math in the source material is undeniably intense. I mean, we're talking about redefining the bedrock of space-time geometry. But the underlying logic is surprisingly intuitive once the actual pattern clicks.
Okay, so let's start at the very beginning of that pattern.
Right.
To understand how the universe scales from the tiny to the massive, we really have to look at that simplest number in existence, the number 1.
Right.
The EGM framework asks us to view it not as a static digit, like we said, but as a vibrating spectrum. So my immediate question is, how do you mathematically turn a solid integer into a vibration?
Well, you achieve that by utilizing a mathematical tool that is actually over 200 years old. It's called the Fourier series.
Okay, Fourier.
Yeah, Joseph Fourier. He was a French mathematician and physicist, and he made an incredibly powerful discovery back in the early 19th century. He basically proved that any periodic waveform, no matter how jagged or weird or complex it looks on a graph, can be perfectly constructed by adding together a series of simple, smooth sine and cosine waves.
Oh, I've actually seen this concept used in audio engineering.
Oh, really?
Yeah, if you take a really harsh, buzzing synthesizer sound, it looks like a harsh, jagged line on a computer monitor.
Right, right.
But the software can actually break that harsh sound down into dozens of pure, smooth, individual musical notes, all playing at different volumes at the same time.
That is a perfect real-world application of it. MB3 compression uses a very similar concept, actually. It is a direct mathematical example of wave function superposition. You superimpose, or basically stack simple waves to build a complex shape.
Okay, I follow.
So the EGM framework takes this centuries-old tool and exploits its dual nature. Because if you can build any complex shape by stacking simple waves, you can also run the whole process in reverse.
You can tear it apart.
Exactly. You could take any shape, or even a perfectly flat, constant line, and deconstruct it into an infinite series of those constituent waves.
So wait, the EGM physicists use this Fourier tool to deconstruct gravity?
Ultimately,
Yeah.
yes. But to get there, their very first step is to mathematically build the number 1 using this method.
Okay.
So they start with a geometric shape called a unit amplitude square wave.
Let me make sure I'm visualizing this correctly. A square wave that looks like the battlements on top of a castle wall, right?
Yes, perfect analogy.
So the line goes straight up to +1, stays completely flat for a moment, then drops straight down through 0 to -1, stays flat, and then jumps straight back up to +1 again.
That is exactly what it looks like. It oscillates between +1 and -1 in these sharp right-angled steps. Now, the derivation applies a really crucial modification here. They take that oscillating square wave and they fully rectify it.
Rectify it.
Yeah. In mathematical terms, they take the absolute magnitude of the entire function.
Okay, so taking the absolute value, that means no negative numbers are allowed to exist at all.
Correct. When you apply an absolute value, those castle battlements that dip down to -1, they are forced to flip upwards.
Oh, I see.
They become +1. So instead of a line bouncing up and down, the result is a continuous, perfectly flat, constant line resting at exactly 1.
And tell me if I'm jumping ahead, because we built that original square wave using a Fourier series.
Yep.
Meaning we built it by stacking countless invisible vibrating sine waves. That flat line we ended up with isn't actually a solid object, is it?
And that is the conceptual breakthrough right there. The line looks flat, and it functions mathematically as exactly 1, but underneath, it is composed of a vast spectrum of harmonic waves.
Wow.
They're perfectly balancing each other out, peaking and troughing in such a precise choreography that they create this flawless illusion of a solid constant.
Okay, so bringing my audio engineer analogy back for a second. It's like trying to create a perfectly flat, solid, continuous tone, like a single, unwavering note. But instead of just pressing one key on a synthesizer, the engineer builds that solid tone by perfectly blending millions of different microscopic, vibrating sound frequencies. To our human ear, it sounds like one solid note. But if you look at the raw data, it's a massive, chaotic choir of vibrations.
A choir of vibrations. I love that. That's a great way to put it. The source material formally titles this mathematical construct the unit harmonic operator, or the UHO.
The UHO.
And it is represented in their equations by the Greek letter theta as a function of time. The UHO is, quite literally, a fully quantized version of the number 1.
I have to admit, quantized number 1 is a fantastic phrase, but I want to dig into the mechanics of this choir you mentioned because the source points out a very specific, weird detail about how the UHO is built.
Oh, about the harmonics.
Yeah, because when you normally construct a square wave using a Fourier series, you naturally generate a whole ladder of frequencies. You get odd harmonics, like the 1st, 3rd, 5th, 7th frequencies.
Right.
And you get even harmonics, too, the 2nd, 4th, 6th. But when they flip the negative parts up to make that flat line, half the choir goes quiet.
Yes. Something really beautiful happens purely as a result of the mathematics. When you fully rectify the wave to create a constant +1, the even harmonic modes, the 2nd, 4th, 6th, and so on, They perfectly sum to zero across the equation.
They just vanished.
They completely cancel themselves out.
Ugh.
So mathematically, they are entirely discarded. The quantized number one is composed exclusively of odd harmonic waves.
Now, as someone reading this, my first instinct is, so what? I mean, why do we care if the even numbers disappear from a math equation?
Because it tells us that this mathematical trick aligns perfectly with one of the most fundamental laws of the physical universe,
Which is?
the principle of least action. Nature is, at its core, incredibly lazy.
Lazy in what way? Like it takes shortcuts.
Exactly. In the sense that physical systems will always evolve along the path of least resistance. Light bends through glass at the exact angle that takes the least time. A ball rolls down a hill via the path that requires the absolute minimum expenditure of energy. The universe does not waste effort.
Okay, I'm tracking with you.
So, if nature were to maintain those even harmonic waves in the quantum vacuum, it would be expending energy to sustain vibrations that ultimately just sum to zero anyway. It would be highly inefficient. By discarding the even harmonics naturally, the UHO math inherently satisfies this least action principle. It represents the lowest possible energy state required to maintain that solid number one.
Oh, that is so cool. It's like nature optimizing the system. It just throws out the useless code.
Exactly.
So now we have this unit harmonic operator, the UHO, which is just the number one, but built out of maximally efficient, vibrating odd harmonics. I want to connect this directly to physical reality for the listener.
Let's do it.
If I'm standing in an elevator and I feel the solid, constant pull of gravity, say 9.81 meters per second squared pulling me into the floor, is the EGM framework suggesting that the solid force of gravity is actually composed of billions of tiny, vibrating gravitational acceleration waves?
That is precisely what the framework implies, yeah.
Yeah.
When you multiply the standard equations of gravity by this quantized number one,
Yeah.
you reveal that any given point in the gravitational acceleration field is not a single smooth static value.
Right.
It is an incredibly dense spectrum of discrete waves.
Uh.
To give you a sense of scale, the source calculates that for a massive macroscopic object like the Earth, the local vacuum contains roughly 10 to the 28th power harmonic modes.
Okay, let me write that out in my head. That is a 1 with 28 zeros behind it. That is an incomprehensible number of waves.
Unimaginably huge. And that sheer density is why gravity feels perfectly smooth and constant to our human senses. The discrete, grainy structure of the waves is absolutely there, but they are so numerous and oscillating so rapidly that our macroscopic physical reality averages it out into what perceives as a solid, unyielding pull.
Okay, I do have a technical question here because I was reading the footnotes in the source about Gibbs oscillations.
Ah, yes, good catch.
It sounded like a bug in the math to me. If you build a square wave out of curved sine waves, don't you get a little bit of fuzziness or overshoot right at the sharp corners where the wave drops? Is our gravitational choir slightly out of tune?
Gibbs oscillations, or the Gibbs phenomenon.
Yeah.
It is a very astute mathematical observation. And yes, when you approximate a sharp square wave with a finite number of smooth sine waves, you get tiny mathematical ripples or overshoots right at those sharp vertical edges. But the source explicitly addresses why this isn't a problem for the physics. Because the UHO represents the absolute ground state of the quantum vacuum. Its period, meaning the time it takes for one full cycle of the fundamental wave, is said to be astronomically enormous.
How enormous?
The physicists set the period to 10 to the 100th power gigayears.
Yeah, hang on. The universe itself is only about 13.8 billion years old. 10 to the 100th gigayears is, well, it's virtually eternity.
It is far, far longer than the current lifespan of the cosmos. Because the fundamental wave is stretched out over such an incomprehensible length of time, those tiny edge ripples, they are pushed incredibly far out into the distant future.
Oh, they just never happen in our timeline.
Exactly.
Yeah.
Furthermore, their amplitude decays so massively because of the sheer number of high-frequency modes packed into the space between, like, those 10 to the 28th modes for Earth, that they become completely physically irrelevant.
So they're just a math artifact.
Right. They are a mathematical artifact of the Fourier series that will never, ever register in any physical measurement. For all practical, observable purposes, the UHO is exactly, flawlessly one.
Okay, so if you are listening to this right now, I want you to imagine your own weight. You're sitting in your car or maybe running on a treadmill, and you feel that solid physical force holding your feet down. This new framework says you should imagine that force not as a solid, static hand pushing on you, but as a chorus of billions upon billions of invisible vibrating waves locking you to the ground.
Yeah, it connects your physical body directly to the underlying hum of the quantum vacuum.
It's a wild mental image. Okay, so we have established our quantized, number one, the UHO. It's vibrating, it's maximally efficient, it's beautiful math. But what do we actually do with it?
That's a big question.
Right. The source document's next step is bold. They inject this UHO directly into the most robust, battle-tested equations in all of physics, Einstein's field equations for general relativity. But before they can just plug it in, they hit a roadblock,
A
right?
huge roadblock.
They have to mathematically prove something incredibly specific, that electromagnetism and gravity are actually related.
Which is a massive hurdle. If you were going to integrate the quantum vacuum, which is inherently tied to electromagnetic properties, like virtual photons popping in and out of existence, with general relativity, which is purely the geometry of gravity, you need a mathematical bridge.
You can't just assume they talk to each other.
Exactly. You cannot just assume they interact. You have to prove that an electromagnetic variation can induce a gravitational effect. And to establish this, the EGM derivation utilizes a technique called Buckingham pi theory, or BPT.
Buckingham pi. Okay, I am familiar with dimensional analysis from a purely engineering standpoint, like calculating stress on a beam. But how does BPT work in theoretical physics to prove a connection like this?
Well, dimensional analysis is fundamentally a way of testing the physical relationship between different parameters by looking purely at their units of measurement like mass, length, time, and charge. Think about designing an airplane wing. Before you even build a prototype or put it in a wind tunnel, you know that the speed of the plane, the density of the air, the physical shape of the wing, and the viscosity of the air all interact to create lift.
Yeah, they have to.
Buckingham pi theory allows you to organize these very different physical variables into a single dimensionless equation. It reveals the deep mathematical relationships between the variables, independent of whatever specific numbers you might plug in later.
Okay, so if they're hunting for a bridge between electromagnetism and gravity, what specific variables did they throw into the Buckingham pi blender?
They postulated that if a relationship exists, the key physical ingredients would have to be acceleration, magnetic field strength, electric field strength, field frequency, physical position in space, and electric charge.
Okay, 6 variables.
Yes. They structured these 6 variables into a matrix within the Buckingham pi framework to see how the units of mass, length, time, and charge balanced out.
And when they crunched the matrix, the result was highly unexpected. Like one of those 6 key ingredients completely vanished from the final equation.
It evaporated entirely. When they mathematically solved the matrix to find the unknown indices required to balance the equation, the index for electric charge solved to exactly -2.
Okay, stop right there. I want to make sure I understand why that matters. Why does an index of -2 make a variable disappear?
So in the mathematics of this specific geometric setup, an index of -2 indicates an inverse square relationship. But because of the way the variables were constructed to balance the system's overall units to 0, that Q to the -2 dependency algebraically canceled out the requirement for charge altogether.
Wait, really?
Yeah, the final balanced equation simply did not contain the variable for electric charge anymore.
But wait, if the charge variable vanishes,
Mhm.
what does that actually prove physically?
It is a profound proof. It proves that the resulting acceleration described by this new equation is strictly a gravitational force, not a Lorentz force.
Okay, can you break down the difference there for those of us who don't have a physics degree?
Sure. A Lorentz force is the physical force exerted on a charged particle moving through an electric and magnetic field.
Mm.
It absolutely requires electric charge to exist.
Cool, so like a magnet pushing on a piece of metal.
Well, specifically, an electron experiences a Lorentz force, but a neutral neutron does not, because it has no charge.
Ah, I see.
Because the charge variable mathematically evaporated from the EGM equation, it means the acceleration they are describing cannot be a Lorentz force. Therefore, the resulting acceleration must be purely gravitational.
Wow.
They successfully derived a direct mathematical relationship demonstrating that electromagnetic properties, specifically the frequencies and field strengths of the vacuum, can induce a purely gravitational acceleration, completely independent of any electrical charge.
Which opens the door to something the source calls metric engineering. And I'll be honest, the first time I read that phrase, it sounded like a concept from a sci-fi novel about warp drives.
It certainly sounds futuristic. But in this context, it is a very grounded theoretical concept. Metric engineering refers to the theoretical ability to construct or engineer gravitational effects locally via wave function superposition.
So manipulating the waves to make gravity.
Essentially, yes. If you can understand and theoretically manipulate the electromagnetic wave structure of the quantum vacuum, you can, in theory, manipulate the local geometry of spacetime. You can engineer gravity.
That is wild. Just wild. But getting back to the derivation, we now have our bridge. We know EM and gravity speak to each other, so we can finally introduce our vibrating number one, the UHO, into Einstein's gravity equations. And the source document offers two different methods to do this. They call them Method 1 and Method 2.
Yes. And it is vital to emphasize here that both methods yield the exact same physical predictions.
So they aren't competing theories.
No, not at all. They are mathematically equivalent. They just represent two different conceptual vantage points of the exact same physical reality.
Okay, let's start with Method 1. The document describes this as a top-down approach that is engineered.
Right. Method 1 operates strictly in the time domain. It's a very direct mathematical insertion. You take Einstein's field equations, specifically the Ricci scalar component.
Let's define the Ricci scalar for a moment. If general relativity is a trampoline, what is the Ricci scalar doing?
That's a good analogy. If space-time is the fabric of a trampoline, the Ricci scalar is a single localized number that acts like a curvature score.
A curvature score, okay.
Yeah, it tells you exactly how much the fabric is warped or deformed at one single microscopic specific point.
Okay, so Method 1 takes this curvature score at a single point in space.
And it simply multiplies it by the UHO, or vibrating number 1, because the UHO functions essentially as the number 1. Multiplying by it doesn't break or alter Einstein's fundamental laws. It simply reveals a hidden layer.
Right, because multiplying by 1 changes nothing overall.
Exactly. It demonstrates that at any single point in space, that curvature score is not perfectly static. It is dynamically fluctuating over time, driven by those underlying Fourier harmonics.
It's like zooming in on a high-definition photograph. From far away, a red wall looks like a perfectly smooth, solid red block.
Right.
But if you take a magnifying glass and zoom in on a single microscopic pixel on your TV, you see that the pixel is actually flickering, refreshing its color hundreds of times a second.
That's an excellent visualization. Method 1 evaluates a single point in space, but reveals how it vibrates in time.
Okay, so what about Method 2? The source calls this bottom-up and says it operates via the action principle in the spatial domain.
So if Method 1 is looking at a single pixel flickering over time, Method 2 is stepping back and looking at the entire screen at a single frozen fraction of a second.
Oh, interesting.
Instead of focusing on one point over time, Method 2 freezes time and averages the quantum fluctuations across a wide physical slice of space. And to do this, it introduces a concept called an effective metric.
The effective metric. And the stepping stone to get there is something called the scalar condensate. I want to spend a minute here because the source uses a brilliant analogy comparing the quantum vacuum to an ocean. How does that explain the condensate?
Okay, imagine the absolute ground state of empty space, the quantum vacuum, as a vast ocean. Even when the weather is perfectly calm, no wind, no large waves crashing on a beach, the surface of the water isn't perfectly like glass.
Well, there's always movement.
It is constantly moving with tiny microscopic chaotic ripples. In the physical vacuum, those ripples are space-time fluctuations, represented mathematically by the harmonic modes we've been discussing. Even empty space is jittery.
Right, the vacuum is never truly empty or still.
Exactly. Now, the scalar condensate is a mathematical tool that acts like a dial. It averages out all of those tiny ripples across a specific area of space. In a theoretical realm of perfectly empty space, what physicists call Minkowski spacetime, devoid of any mass whatsoever, the ripples are completely relaxed and undisturbed.
So what does the dial say?
The scalar condensate dial points exactly to the number 1.
Okay, so deep in the intergalactic void, light years from the nearest star, the dial sits at 1. But what happens to the dial when you introduce something real into that ocean? Say, a single proton.
When you drop a mass, like a proton, into that quantum ocean, it physically displaces the vacuum. Its mass squeezes those tiny ripples.
It squeezes them.
Yeah, because the ripples are now being compressed and polarized by the mass, their spatial average changes. The scalar condensate dial shifts ever so slightly away from 1.
So the mere presence of physical matter disturbs the baseline jitter of empty space.
Yes.
Yeah.
And this is where the elegance of Method 2 really shines. That tiny shift in the scalar condensate dial acts as a multiplier on the background metric of space. It generates the effective metric.
Wait, so the shift is the gravity?
Yes. That tiny shift in the dial is the mechanism that tells gravity how strongly to curve spacetime in response to the vacuum being polarized by the proton's mass.
That is mind-bending. The matter pushes on the vacuum ripples get squeezed, And that squeezing is the curvature of space-time.
Precisely. In method 2, the UHO isn't just plugged in from the top down. It is mathematically derived from the bottom up as the spatial average of the inverse of this scalar condensate. It creates a beautifully elegant feedback loop. A massive push by physical matter yields a specific response in the vacuum, connecting microscopic quantum ripples to macroscopic gravitational curvature.
Okay, so we've established this jittery quantum ocean. We know that matter, whether it's a single proton or a giant planet, is actively pushing against the quantum vacuum, squeezing the ripples and changing the dial.
Right.
But that raises an incredibly obvious question for me. Is there a limit? Like, exactly how much does matter push on the vacuum, and exactly how much does the vacuum push back?
And that question brings us to the most vital rule in the entire EGM framework.
The big one?
The big one. If there is one concept the listener internalizes today, it is this specific mechanism. It is the absolute linchpin of the theory, the principle of mass-energy equilibrium.
Okay, let's build up to it, starting with a concept most people are familiar with. Special relativity. Einstein's most famous equation, E equals mc squared.
Which fundamentally dictates that mass and energy are not two separate things. They are two sides of the same coin. Mass is essentially congealed concentrated energy.
Right. So the source document argues that if E equals mc squared is an unbreakable law of reality, then a perfect localized equilibrium must exist. Specifically, it states that the mass energy density of any physical object must be exactly equal to the spectral energy density, the SED of the surrounding quantum vacuum.
This is a massive conceptual leap. It proposes that the local quantum vacuum can never, under any circumstances, contain more energy than the actual physical matter present in that local area. The mass of the object physically dictates the energetic limit of the vacuum surrounding it.
Let's visualize this so it's not just abstract math. The source uses a really great example. Imagine a simple 1 kilogram lead ball sitting on a wooden table right in front of you.
Okay, a standard 1 kilogram sphere of lead.
The EGM framework states that if you could somehow isolate and measure the quantum vacuum immediately surrounding the surface of that lead ball, the absolute maximum amount of energy that can exist in that vacuum in the form of fluctuating spectral energy density is exactly the energetic equivalent of 1 kilogram of mass. No more, no less.
It creates a strict state of QV equilibrium, or zero-point field equilibrium. The physical mass of the lead ball displaces spacetime, and the fabric of spacetime pushes back against the surface of the ball with the exact same amount of energetic force to achieve perfect balance.
It's like Newton's third law.
Exactly. Every action has an equal and opposite reaction, but applied to the very architecture of reality.
No, when I first read that, my reaction was, well, yeah, that sounds like common sense. I mean, a system wants to be balanced. But why is stating this such a revolutionary big deal in physics?
Because in the realm of mainstream quantum physics, applying that common sense balance solves one of the most persistent, headache-inducing mathematical nightmares in the history of the field.
Oh, the nightmare.
Yeah. It is a problem known as ultraviolet divergence.
Ultraviolet divergence. I mean, it sounds like the title of a bad 90s sci-fi thriller. What exactly is it?
To understand the problem, you have to look at how physicists traditionally try to calculate the total energy of the quantum vacuum. Using standard quantum electrodynamics, they have to mathematically add up the energy of all the possible vibrating frequencies in empty space.
Okay, so counting the ripples.
Right. Yeah. The problem is, standard quantum mechanics doesn't provide a natural reason to stop counting. You add the low frequencies, then the higher frequencies, then the even higher frequencies, vibrating faster and faster, deep into the ultraviolet range and beyond, endlessly.
So if you are adding up an infinite number of increasingly energetic frequencies, your total sum is going to be infinite energy.
Exactly. The equations mathematically blow up to infinity. And you cannot do functional physics with infinity.
Because it breaks the math.
It breaks reality. If the local vacuum actually possessed infinite energy, the entire universe would instantly violently collapse into a black hole. Obviously, we were sitting here talking, so that hasn't happened.
Thank goodness.
So to fix this broken math, mathematicians and physicists for decades have utilized a workaround, a trick called renormalization.
The source material is pretty blunt about this. It literally calls renormalization fudging the numbers.
And they are not alone in that critique. I mean, many of the greatest minds in physics, including Richard Feynman, who literally won a Nobel Prize for his work in quantum electrodynamics, he deeply hated renormalization.
What did he call it?
He famously called it a Dippy process. Renormalization is essentially sweeping the infinity under the rug. Physicists mathematically insert an arbitrary cutoff point. They basically say, we will stop counting the frequencies here just so the math doesn't explode and we can get on with our practical calculations.
Just picking a number out of a hat.
More or less. And it works incredibly well for making experimental predictions, but philosophically, it feels dirty. It implies the foundational theory is incomplete.
And this is where the EGM framework sweeps in and theoretically saves the day.
Completely. Because the EGM framework institutes this strict energetic boundary. The ironclad rule that the vacuum energy can never exceed the local matter present. It creates a natural physical ceiling.
A ceiling. Okay.
You no longer have to artificially, arbitrarily cut off the frequencies. The mass of the object itself mathematically dictates exactly where the counting stops. The infinities disappear naturally. Ultraviolet divergence is completely resolved inherently, with zero fudging required.
Okay, I follow that, but I want to pause and challenge the premise slightly because I'm trying to picture this at different scales.
Sure.
The 1 kilogram lead ball example works beautifully because a lead ball has a hard, distinct physical surface. I can mentally visualize the vacuum pressing right up against the edge of the lead. But what happens when we look at subatomic particles? A proton or an electron doesn't actually have a hard surface, right? They are described as fuzzy clouds of probabilities. So if there is no hard surface, where does the vacuum stop pushing? Where does the equilibrium actually happen?
That is an excellent pushback, and it highlights one of the most brilliantly elegant turns in the entire EGM derivation. You are absolutely right. A proton does not possess a hard outer shell like a billiard ball. So, for subatomic particles, the EGM equilibrium principle works in reverse.
What do you mean it works in reverse?
Think about the lead ball again. You know its physical radius, where the surface is, and you use that known radius to calculate the limit of the vacuum energy pressing against it.
Okay.
But for a single proton, you know its mass, but you don't inherently know where its definitive boundary is. So the physicists take the equation and set it to strictly require perfect equilibrium. They mathematically demand that the vacuum energy exactly matches the proton's known mass energy.
And then what?
And then they let the math solve for the missing variable. They let the math dictate exactly where that spatial boundary must be located in order to achieve that perfect energetic balance.
Oh, wow. So they reverse engineer the geometry.
Precisely. The mathematical output of this equilibrium calculation literally generates the physical radius of the particle. The spatial boundary where the vacuum perfectly balances the particle's mass organically becomes the physical size of the particle.
That is genuinely unbelievable. The vacuum isn't just blindly pushing against a pre-existing proton. The vacuum's fundamental need for energetic equilibrium is actively defining how big the proton is allowed to be.
You've hit the nail on the head. The local geometry of space-time and the physical dimensions of the particle are intimately, inextricably linked. They are codependent. You cannot define the size of the matter without defining the structure of the vacuum surrounding it.
Which brings us to the grand payoff of the framework. We have our quantized number 1, that humming, maximally efficient UHO built from odd Fourier harmonics. And we have combined it with this strict, universe-defining rule of mass-energy equilibrium. When you lock those two concepts together, you forge the master key.
You generate the quantum vacuum spectral limit, the QVSL.
I want to explicitly emphasize this for everyone listening because this formula is the core focus, the main thesis of today's deep dive. I want everyone listening to write this down in their head. The equation to remember is this. The number 1 plus the principle of mass-energy equilibrium fundamentally generates the quantum vacuum spectral limit.
Yes.
And that limit is what results in scale unification. Let me repeat it to cement it. The number 1 plus mass-energy equilibrium generates the QVSL.
It is the absolute heart of the EGM framework. Everything flows from that union.
So we have this master key, the QVSL. What exactly does it do functionally in the math?
The QVSL acts as the definitive finite frequency cutoff. Remember our discussion about solving ultraviolet divergence?
The infinite math problem.
Right. The QVSL is the physical and mathematical manifestation of that solution. It dictates the absolute maximum number of harmonic modes the quantum vacuum is allowed to possess locally before it perfectly balances the mass of the matter present.
It is the architectural ceiling.
It is the ceiling. But what is truly beautiful about the EGM derivation is how it simplifies this complex ceiling into 2 incredibly elegant, concise physical constants. They are labeled in the paper as Saint sub n and Saint sub g.
Break those down for me. What do they represent?
Saint sub n relates directly to the harmonic cutoff mode number. You can think of it as the maximum number of individual ripples allowed in that area of the quantum motion.
Okay, the number of ripples. And Saint sub g.
Saint sub g relates to the harmonic cutoff frequency. You can think of that as the absolute speed limit for how fast those ripples are physically allowed to vibrate.
And what are these new constants constructed from? Like, are we inventing entirely new crazy numbers to make the math work?
Not at all. And that is why this theoretical framework is commanding so much attention. These two ceiling constants are built entirely from the most universally accepted bedrock fundamental constants in all of physics.
The classics.
The absolute classics. They're constructed solely from c, the speed of light in a vacuum, g, Newton's gravitational constant, and h, Planck's constant, which is the foundational unit of quantum action.
Think about how profound that is. The universe didn't require some new magical rule of everything number. It just took its own internal speed limit, the speed of light, its own intrinsic weight and curvature with gravity, and its own microscopic pixel size with Planck's constant, and wove them together to build the ceiling.
It is deeply poetic. No arbitrary numbers were invented. No experimental data was fitted after the fact. Just the pure, unadulterated fundamental properties of the universe dictating its own structural limits.
I want to bring this abstract math directly back to you, the listener. We have been deep in the weeds of theoretical physics today, but this isn't just chalk on a blackboard. This QVSL, this frequency cutoff, it is the literal energetic speed limit of the empty space occupying the room you are sitting in right now.
It is actively functioning all around you.
The space between you and your screen, the air inside your car. The QVSL is the invisible mechanism preventing the fabric of reality in your immediate vicinity from infinitely vibrating itself apart. It is what keeps the vacuum stable, allowing complex matter, biology, and your own consciousness to exist within it.
If the QVSL did not organically arise from this mass-energy equilibrium, the local vacuum would be violently, instantly unstable. It is the architectural load-bearing beam of spacetime.
Okay, we have the theory, we have the limits, we have the elegantly derived constants, but as any rigorous scientist will tell you, a beautiful mathematical theory is utterly worthless if it doesn't map to reality.
True, it has to pass the test.
Does this math actually predict the real world? This is where the QVSL is put to the fire. This is where we see if scale unification is real.
And scale unification is the ultimate unforgiving test. It is one thing for a physicist to design a mathematical framework that cleverly solves a single specific anomaly. It is an entirely different magnitude of achievement to design a framework from first principles that perfectly predicts physical reality across all conceivable sizes of nature, with zero free parameters.
Let's clarify zero free parameters for a second. That means they didn't have any dials to twist at the end to make the math match the experiments.
Exactly. A free parameter is a variable you can tweak to fit observation. In EGM, the inputs are completely fixed by those fundamental constants we mentioned, d, c, g, and h.
So the math is rigid.
Entirely rigid. It either organically produces the correct physical measurement or the entire theory fails completely. There is no wiggle room.
Let's start small and see if it passes. Particle physics. We discussed how the equilibrium principle reverse engineers the radius of subatomic particles. When they ran the QVSL equations, did the math actually spit out the correct physical size for a proton?
It did, and we are not talking about a ballpark approximation. The QVSL derived the proton root mean square charge radius from absolute first principles, and that purely mathematical derivation exactly matched the highly precise, cutting-edge experimental verifications performed by the CELEX collaboration in 2001, and later the PRAD collaboration at Jefferson Lab in 2019 and 2022.
So wait, they didn't measure the proton in a lab and then work backward to write math that fit the measurement? They started with the concept of the vibrating number one in mass equilibrium, ran the math forward, and it naturally predicted exactly what the billion-dollar particle accelerators eventually measured.
Yes, and it successfully repeated the feat. It utilized the exact same framework to derive the neutron mean square charge radius, perfectly mapping to decades of established experimental data, starting with the Kopecky and Rees measurements in 1995.
But wait, if we are talking about the radius of the proton, I remember a massive controversy in physics a few years ago, something called the proton radius puzzle.
Oh, yes. That was a big deal.
For a long time, different types of highly accurate experiments were giving physicists two completely different answers for how big the proton was. Does the EGM framework address that puzzle?
It doesn't just address it, it completely resolves it mathematically. The proton radius puzzle was a major crisis in the field. Historically, experiments that bounced standard electrons off protons gave one specific measurement, the code-data average.
Okay.
But newer, highly sensitive experiments that use muons, which are essentially heavy cousins of electrons, returned a slightly different, smaller radius. The physics community was highly polarized, debating which experimental method was flawed.
It sounds incredibly frustrating, like trying to measure the width of a table using a wooden ruler and then measuring it again with a metal tape measure and getting two different lengths. You know the table didn't change size, so one of your tools must be broken.
That was the prevailing assumption. One tool was broken. But the EGM framework proved something remarkable. It demonstrated that both measurements are actually entirely correct,
Wait, how can they both be correct if they're different?
because they are simply measuring slightly different geometric manifestations of the exact same underlying reality. The mathematical framework organically showed that the quantum vacuum equilibrium radius, the boundary we discussed earlier, perfectly yields the smaller Celex and Prad-muon measurements.
Right?
Meanwhile, the larger codata average mathematically corresponds exactly to the proton's electric radius. The framework mapped the physical difference natively. It resolved the intense tension by proving how both distinct radii emerge naturally from the exact same vacuum dynamics.
That is a staggering achievement, so it absolutely crushed particle physics. Let's scale the math up slightly and look at atomic physics.
Still utilizing the exact same QVSL mathematics, and specifically incorporating the neutron charge distribution they had just derived, the EGM framework successfully formulated the Bohr radius.
Let's define the Bohr radius. That is the fundamental physical distance between the nucleus of a hydrogen atom and its single orbiting electron in its ground state, right?
Correct. It is a vital foundational cornerstone of all quantum mechanics and chemistry. And the EGM framework derived this distance strictly from vacuum properties, achieving a result with greater than 99.98% similarity to the universally accepted experimental value.
99.98% accuracy from first principles.
And they pushed it even further into atomic structure. They utilized the framework to derive the wavelength of the first term of the Balmer series.
The Balmer series. That relates to how hydrogen emits specific colors of light when its electron jumps between energy levels, correct? The spectral lines?
Yes, the visible spectral lines of hydrogen. The framework derived this specific light wavelength directly by counting the harmonic modes of the quantum vacuum. The mathematical agreement with experimental reality was greater than 99.87%.
Okay, so particle physics, check. Atomic physics, check. The math scales from the nucleus to the atom flawlessly. Now let's swing for the absolute fences.
The big one.
Let's scale up to cosmology. We are jumping from the microscopic size of a single hydrogen atom to the macro expansion of the entire observable universe. How does the EGM framework even attempt that leap?
This is where the true jaw-dropping power of scale unification becomes undeniable. The process is a logical cascade. Using the particle physics derivations they had already rigorously established, the framework first mathematically predicted the intrinsic mass energy of a single individual photon.
Wait, I thought photons, particles of light, were completely massless.
They have zero rest mass, meaning if they are somehow stopped, they weigh nothing.
Yeah.
But because they are constantly moving at the speed of light, they possess mass energy or momentum due to relativity.
Ah, okay.
So the framework calculated this incredibly minute mass energy, and then from that microscopic photon mass, they derived the Hubble constant entirely a priori.
Let's break that down. The Hubble constant is the numerical rate at which the universe is expanding, galaxies flying apart from one another.
Right.
And a priori means they derived this massive cosmological number mathematically, purely from theory, before they had the precise experimental astronomical data to check it against.
Exactly. In 2008, the physicists published their EGM framework prediction. Based on their vacuum derivations, they stated that the Hubble constant would be exactly 67.1 kilometers per second per megaparsec.
A megaparsec being a massive chunk of cosmic distance, about 3.2 million light years. So predicting 67.1 in 2008. What was the accepted standard scientific measurement at that time?
In 2008, the widely accepted value published by the Particle Data Group, based on telescope observations, was around 73.
73.
So the EGM mathematical prediction of 67.1 was significantly, glaringly lower.
If I am a physicist in 2008 and the consensus says 73 and a new paper claims it's 67 based on vibrating vacuum numbers, I imagine they were met with serious skepticism. That is a massive discrepancy.
It was a very bold, highly risky prediction to put in print. I mean, if they were wrong, the entire cosmological application of the framework would be immediately dismissed.
Right.
But 5 years later, in 2013, the European Space Agency launched the Planck satellite.
Okay.
It was the most sensitive, sophisticated instrument ever created to measure the cosmic microwave background. It returned its definitive, highly anticipated measurements of the universe's expansion rate.
And what was the Planck satellite's official measurement?
67.3.
Oh, wow.
67.3.
That is stunning. 67.1 versus 67.3. That's insane.
The EGM framework, derived entirely from the vibrating harmonics of the number one and the principle of mass-energy equilibrium, accurately predicted the expansion rate of the entire universe 5 years before humanity's best orbital satellites were sensitive enough to measure it.
That is the absolute definition of predictive power in science. You predict reality before reality is officially recorded.
And they demonstrated that predictive power again with another massive cosmological metric, the CMBR, or cosmic microwave background radiation.
The heat left over from the Big Bang.
Exactly, the thermal afterglow of the Big Bang itself lingering in the vacuum. In 2008, the accepted temperature of the CMBR was 2.725 Kelvin. The EGM equations, running on their vacuum limits, predicted an order of magnitude improvement in resolution, calculating the precise temperature at exactly 2.7248 Kelvin.
Let me guess the timeline here. 5 years later.
Exactly. In 2013, the Planck satellite data resulted in the official value being updated to 2.7255 Kelvin, validating the incredibly tight predictive trajectory of the EGM math.
I am just sitting here marveling at the sheer scope of this. Think about the narrative we constantly hear in popular science news. We are told over and over that modern physics is fundamentally fractured. It's been broken for a century.
Yeah, the two houses.
We have general relativity reigning supreme over the massive things, the black holes, the spiraling galaxies, and we have quantum mechanics ruling the tiny things, the quarks, the fields, the probability waves, and we are told they speak completely different languages and simply do not get along. But what this deep dive has revealed is that this EGM construct demonstrates that the exact same underlying vacuum structure organically connects the nuclear, the atomic, and the cosmic levels flawlessly.
That is the pure, unadulterated essence of scale unification. It provides a mathematical proof that the universe does not operate using two separate, contradictory rulebooks.
There's only one rulebook.
Just one. The physics that mathematically dictate the microscopic radius of a single proton are the exact same physics that dictate the rate at which galaxy clusters are flying apart from one another across billions of light years. It seamlessly brings particle physics, atomic physics, and cosmology under one single, unified mathematical roof. And it accomplishes all of this by simply starting with the fundamental Fourier harmonics of the number one.
Which brings our journey beautifully full circle back to our primary focus. I want to cement this thesis for everyone listening one final time, because it is that important. By taking the concept of unity, the number one, and mathematically quantizing it through Fourier series, and combining that vibrating state with the undeniable principle of mass-energy equilibrium, the EGM framework organically generates the quantum vacuum spectral limit, the QVSL.
Right.
And this single, beautifully derived limit results in total, undeniable scale unification. 1 plus mass-energy equilibrium generates the QVSL, which results in unification.
It is a profound shift in how we are able to comprehend the deepest architecture of reality. It removes the impossible infinities, it eliminates the need for mathematical fudging, and it reveals a universe that is deeply, naturally, and beautifully harmonized from the smallest subatomic spark to the widest cosmic void.
To you listening right now, thank you for joining us on this incredibly dense, mathematically challenging, but utterly rewarding deep dive.
Thanks for sticking with us.
We asked you to take the absolute foundations of physics, the very gravity holding your feet to the floor, and look at them in a completely radically new way. We really hope you experienced more than a few aha moments as we traveled from the microscopic jitter of the quantum ocean to the macroscopic expansion of the cosmos.
It is a massive amount of conceptual information to process, but recognizing and understanding the underlying simplicity of that scale unification makes the intellectual journey entirely worthwhile.
And before we sign off, we want to leave you with a final lingering thought. We started today's deep dive talking about a child's wooden building block.
The comfortable, static, solid number one.
Right. We learned that underneath that perceived solidity is a chaotic, beautiful chorus of vibrating harmonic waves.
Which naturally leads to a fascinating, almost unsettling philosophical conclusion. Think about what we've established today. If the very fabric of space-time, the solid pull of gravity holding you to your chair, the physical size of the protons making up your body, and the cosmic expansion of the entire universe are all ultimately fundamentally dictated by the harmonic vibrations of the number one, it begs the ultimate question.
Which is?
Is the universe fundamentally a physical object? Or is it, at its deepest, most foundational level, just a perfectly balanced mathematical symphony?
Are we actually standing on solid ground, or are we and everything we know simply riding the frequencies? Something to ponder the next time you drop a wooden block. Thanks for taking the plunge with us.